What's up, warriors? In this video, I'm going to show you how to make a mini model in Excel while you're working any of these types of problems. And the benefit of a mini model is two things. One, you can lay out your computations, kind of see them all and diagnose them if things aren't going right. And the other thing is you can set yourself up to do what if kind of scenarios when variables change. So let's get right to it. We've got this problem right here, and let's just take a look at it. A global survey, sorry about that. Global survey says that 75% of people believe they will catch the coronavirus. Through a local discussion board, Frank asks 100 people in his area what they think. So, first of all, the sample size, which is this first question down here, we know that's 100 people. But more importantly, what type of problem is this? So we have context of what's going on. Okay, well, let's just look at this. A global survey, so that sounds like a big population. Okay, says that 75% of people believe they will catch the coronavirus. So that means 25% of people believe they will not. And this is a categorical variable. Do you think you'll catch the coronavirus? Yes or no? This 75%, because of that population, this is the population proportion. I like to call it P-pop. And it is 0.75. So right off the bat, we need to convert that 75% into 0.75. And so this is a sampling problem. And as I say, the sampling forced, and then the sub part of that force, the smaller part, is we're dealing with P, okay, which is the sample proportion. Okay, so with that in mind, we can move on to our problem. What is the probability that 50% of people or less within Frank's sample think they will catch the coronavirus? So this is giving us a value for P of 0.5. And so what we want to do is see what the probability is of there being a value of 0.5 for P within the sample of N of 100, given that the population proportion is 0.75. So with that, I'm going to take this opportunity to show you some Excel, which is the point of this video in the first place. All right, so the first thing I'm going to do is hang these givens. So I have P-pop, again, which is my way of saying the proportion for the population. And I'm going to hang 0.75 right there. I'm also going to create a space for P and N because they kind of go hand in hand. Now, the thing is, you can put these anywhere. There's no set place for where you're going to put them. So we have a P that's right now is 0.5. So I'm just going to enter 0.5 there. And then my N is 100. Now, I know that for this problem here, I'm going to use the formula Okay, so I know that for this problem, I'm trying to determine the probability for the value of 0.5 being the sample proportion that I'm going to see in my sample. So the first thing I need to do is convert and get a z-score so I can see how far away from 0.75 that value of 0.5 is, and then turn that into a probability. Okay, so I'm going to use this formula right here. All right, so what I'm going to do on my model over here is I'm going to build this numerator first. And we'll call that numerator. You can call it whatever you want to, just as long as you remember what it is. And to get that, I know in my formula I've got to take P, so I'm going to refer to that cell. And then I've got to take the proportion population. And I know that just looking at it, 0.5 minus 0.75 should be a negative number, and sure enough it is. Now the denominator is a little bit tricky, and so that's the first reason we go to Excel in the first place, is to lay out those steps, and so we can see it. Now, obviously, you can do all of this. You could do this whole thing in one cell within Excel. You could do the entire denominator in one cell in Excel. So what I'm going to do is probably a little bit more repetitive and deliberate than advanced warriors might need. That's up to you. I like to kind of give myself a little bit of space, so I call this denominator 1, which is actually the first part of the denominator. So that's going to be, as we see here, it's going to be the proportion population, P-pop, times 1 minus P-pop. So I'm going to refer to that cell right off the bat, times 1 minus that P-pop. That's going to give me the first part. And then I'm going to have a second part that I'm just going to throw N down there. And the third part is going to be the division of those two. So I'm just going to take that P-pop times 1 minus P-pop and divide it by that N. And then the last bit is actually going to be the denominator. So I'm not going to number it. And I'm going to take the square root of that value there. That's still not the z-score. I know to get the z-score, I've got to take the numerator here and divide it by the denominator there. Boom. So that's my z-score. It's not a probability. So the next step would be to go to the z-score table. But I don't need to with a value of negative 5.77 because my z-score, I know, ends at negative 3.69. And that value of probability that corresponds to that z-score is 0.0001. So as I continue out on the left tail of the normal distribution, I go on to infinity, and I get less and less and less of a probability. It's less than 0.0001. But for the sake of science, I can stop and say the probability is less than 0.0001. Very small, that within my sample, less than 50% of people would believe they're going to catch the coronavirus, under the assumption that the proportion of the population is indeed 75%, or 0.75. Now let's look at the second question here. What is the probability that 0.75 of people or more in Frank's sample think they will catch the coronavirus? So here we need to think about this, and with this type of problem, what I would do is first draw it. So we're still going to use this formula. I'm going to put this over here and shrink it down a little bit, because we're going to refer to it, and we already have it built over here. But I want to do a little bit of drawing first, so just so I can keep track of what I'm doing. So this is what we're talking about. Normal distribution, and our proportion population, P-pop as I like to say, is in the middle at 0.75. So what is the probability that 75% of the sample or more in Frank's sample would think they will catch the coronavirus? So if I put my value of P, the question is, where does that value of P go when I have a probability of 75% of people or more? Or I'm looking for the probability. My P is 0.75. Okay, so in this case, my P would line up right on that line. And so that should be 50%, because in the normal distribution, If I'm at the mean and I'm going for 1/2, that is indeed 50%. Now, if you don't trust that, let's just enter it here in our model to see. So if I put 0.75 here for P, and I hit enter, I will get a z-score of 0. And a z-score of 0 equates to 0.50 in terms of a probability. So that all works out. So that's how to do that problem. This is how to build the model. Just to reinforce the second point of doing a model is I can what if this thing. So when you see there, when I did that second problem, I didn't have to rebuild anything. I just had to enter the value of 0.75. So in theory, I could enter values all day long and see what happens. So for example, I could keep running with values of P and say, well, what is the probability of 76% of the proportion in the sample thinking they will catch the coronavirus? Oh, that's a z-score of 0.3. And so we start to move to the right of the mean. The probability gets greater than 50%. And we keep on going. We could go up to 0.8 and see. And we could go out there on the right-hand tail and say, well, what about 0.9 at 90%? Well, it's not very probable. 90% or more, it's less probable that that's going to happen. Or we could go back down to our original start point with 0.5, okay, from this previous problem, and instead we could change n. Well, what is the probability that 50% or less in the sample will think they catch the coronavirus if the sample size increases to n? Okay, and we know that the more the sample size increases, that this value down here will get farther and farther out on the left-hand tail. So let's see if it does. And it sure enough does. A greater z-score means we're farther out there on the left-hand tail. It means that now we're 8 standard deviations away from the proportion, the population of the proportion. What if it goes to 300? That negative 8.16 should go even farther out, probably, I don't know, let's just guess negative 16 standard deviations away. Negative 10, okay? Well, what if we went in closer? What if we had a smaller n? It'll probably be more likely, because that distribution is getting fatter. Okay, so with smaller n, we slowly go back towards, not so much, but we slowly go back towards that population proportion. So that's probably enough for now. Again, the main points, this is how to build a mini model in Excel so that you can solve a problem like this or other problems that look like this. It doesn't have to be a population proportion problem. It could be a population mean. It could be a single value X problem, okay? Do these all have to be down here like this, denominator 1, etc.? No. You can put them wherever you want to. Are there other things? Could I combine steps here instead of having all this? Sure. But the main thing is you can lay out your computations. You don't have to start a new problem, and you can what if, meaning you can explore if a variable changes, how does that affect things?